Hey guys, welcome to Crown Smarts. In this video we want to solve the following functions. We want to differentiate this. We want to find dy dx. Now if you observe, this function looks very interesting. You know why? Here normally if we were to find solve for dy dx in our other videos, when we were solving for dy dx, we had that our y was equal to a function of x. Okay, as everything is written in terms of it. Let us say example 2x plus 3. Here y is the subject of the formula, right? But if you observe in these two questions, you see that you can't make y the subject of the formula here. Okay, and what we are looking for what? Dy dx. And we observe that you can't make y the subject of the formula, so this becomes more difficult to differentiate. Okay, so now we want to differentiate this implicitly. Okay, so this is an implicit differentiation. Now to solve for dy dx, there are things you need to take note of the following. First of all, remember when you are differentiating this, especially when you are differentiating y, you have to treat y as a function of x. Okay, you have to treat y as a function of x before differentiating it. So let's solve the first one and see what we mean by that. So the first one is x cubed plus y cubed is equal to 3xy. Okay, now I want to differentiate everything here with respect to x. I'm differentiating everything here with respect to what? X. So differentiating everything here with respect to x, so I'll have this as d over dx of x cubed plus d over dx of what? Y cubed is equal to, remember whatever you do on the other side of, on this side of the equation, you also do it on the other side of the equation, right? So you have d over dx of 3xy. Okay, so I'm differentiating everything 10 by 10, right? Okay, now if you differentiate x cubed with respect to x, what do you have? You have 3x squared. Now observe that I can't do the same thing here. Do you know why? Because I have y and I'm differentiating this y with respect to x. So now let me introduce something here. So observe that I have here as d over dx of what? Y cubed. Okay, now if I multiply this by what? Dy over dy over dy. Okay, now this doesn't change anything. Do you know why? Because dy over dy is already 1, so 1 times this does not change anything. So I can now switch the denominator. I have this as, sorry, let me take this up. I have this as d over dy of what? Y cubed times dy over what? Dx. Okay, so times dy over dx. So now you see that I can now differentiate y cubed. Now if you differentiate y cubed, you have what? 3y squared, right? Times dy over dx. So what this means in general is whenever I have something like this, okay, I'll first of all differentiate it with respect to y, then multiply it by what? Dy dx. An example, let me write this by the side. Supposing I have y raised to the power of 4, so I'll first of all differentiate this with respect to y. So I'll have this as 4y3. Now multiply it by what? Dy dx. This is when you are differentiating y raised to the power of 4 with respect to what? X. Okay, so you treat this as a function of x. Then when you differentiate it, this is what you get. Now let's go back to our question. So this will be plus, now differentiating this, like we said, we first of all differentiate this with respect to y. What do we have? 3y squared, and then we multiply this by what? Dy dx is equal to, now I can do this 3, remember this is a constant times functions, right? So I can remove the constant out and differentiate the what? The function. Okay, that's part of the rule of differentiation. When you're differentiating a constant times a function, you can remove the constant out and differentiate the function. Okay, Now what we have here now, okay, we haven't differentiated this, right? So we need to find we have to differentiate x and y with respect to what? X. Now we're going to use product rule. Do you know why? Because we are treating y as a function of x, and whenever we have two functions of x multiplying themselves, what do we use? We use our what? Our product rule. So here I'm going to have 3x squared plus 3y squared. We have dy dx is equal to, okay, is equal to 3 into, now using our product rule, so this one I'll take this as our u and take this one as our v. Okay, so if my u is equal to x and my v is equal to y, so my u prime is equal to 1 and my v prime is equal to, if you differentiate y, you have 1 with respect to y, then multiply by dy dx, you have 1 times dy dx. Okay, so using the product rule, u dv dx plus v du dx. Please, u prime and v prime means, u prime means du dx, v prime means dv dx. Okay, so my u is what? 1. Okay, my dv dx is what? My dv dx is dy dx, right? So this is 1 times dy, no, my u is x, sorry please, my u is x, so I have this as x. Now my dv dx is my dv dx is actually v prime, which is dy dx. So I have x dy dx plus, okay, the next one I'll write is v, right? Now what is my v? My v is y, so I put my y. Now what is my du dx? This is my v, right? So what is my du dx? My du dx is 1, so this is y times what? 1. So we close this. Okay, so that's how we differentiate xy. Okay, now the next thing we do is simplify. So this becomes 3x squared plus 3y squared dy dx is equal to, so this gives me 3x dy dx plus 3y. Okay, so we collect like terms. So I'll take this one to the other side, I'll take this to the other side, and I'll bring this forward. Okay, so I have this as 3y squared dy over dx minus this come over, so I have 3x dy over dx. Okay, then taking this to the other side, I have this as 3y minus 3x squared. Okay, so if I factorize dy over dx, I have this as 3y squared minus 3x is equal to 3y minus 3x squared. Okay, so divide both sides by 3y squared minus 3x. I'm left with what? Dy dx is equal to 3y minus 3x squared all over 3y squared minus what? 3x. So that is my dy dx for the first question. Okay, that's my dy dx for the what? For the first question. So my second question, right, is x squared plus y squared minus 6x minus 8y plus 16 is equal to 0. Okay, and we are asked to find dy dx. So now differentiating everything here with respect to x. Now since I have x here, it's easy for me to differentiate this with respect to x, right? So I have 2x plus, now I want to differentiate y squared with respect to x. first of all, I will differentiate with respect to y. I'll have it as 2y. Then because I'm differentiating with respect to x, I'll multiply by what? Dy dx minus, now differentiate 6x with respect to x, you have what? 6. Okay, differentiate 8y with respect to x, I have 8 dy dx. Okay, I hope you're not confused. Remember, I have 8y and I'm differentiating 8y with respect to x. Okay, so this will be, since it's a constant, that means I'm only differentiating this one, so this will be 8 times. Now since I'm differentiating y, I'll differentiate y with respect to y, that will be 1 times. Since I'm differentiating originally with respect to x, this will now be times dy over what? Dx. So this will be 8 dy dx. Okay, so plus, now if you differentiate a constant, what do you have? 0 equal to, remember, whatever you do on the other side of the equation, you do it on the other side, right? So if you differentiate 0, you still have what? 0. So I'm collecting like terms here. I'll take this to the other side and I'll take this one to the other side, so I'm left with what? 2y dy dx, okay, minus 8 dy dx is equal to, so if I take 2x to the other side, I have minus 2x. If I take 6 to the other side, I have plus 6. Okay, now if I factorize dy dx here, I have this as 2y minus 8 is equal to minus, let me not use minus, let me say plus 6 minus 2x. I brought this one in front, so if you bring this one in front, you have plus 6 minus 2x. Okay, so now therefore my dy dx is equal to, divide both sides by 2y minus 8. I have this as 6 minus 2x all over 2y minus 8. So therefore my dy dx is simply this. Thank you very much for watching this video. Please kindly subscribe. Thank you.